Hello, pre-calculus. Here's your do now. Go ahead and hit pause while you work this one out. Um, cool. Using the opposite, adjacent, and hypotenuse sides of the triangle, we're just going to construct these three trig ratios. So the sine is going to be the opposite over hypotenuse, or radical 3 over 2 over 1. Division by 1 gives us the same thing we started with, so radical 3 over 2. For cosine, it's a half over 1, and again, dividing by 1 gives us just a half. And for tangent, we get a little bit of a mess here because we got radical 3 over 2 over 1 half. Once we clean that thing up, we just get radical 3. And let's try a second do now. We got the hang of that one. Go ahead and hit pause again. And same three trig ratios. Ready, go. Wow, cool. That was great work. So for sine, this time y over 1, y divided by 1 is just y. Cosine, x over 1, so we get just x. And tangent, y over x, and we can't clean that one up at all. Okay, so today we are learning about using unit circle coordinates, and the reason why we're going to be using those is for our learning target, we're going to be able to evaluate trig ratios using the unit circle. So in order to do this, first of all, let's focus in on that word evaluate. It's one of those math direction words that a lot of times we just like gloss over and we're like, find the answer. Right. Okay. So evaluate, the root word is value, which tells us our final answer is going to be a value. It's going to be a number. The place we get that number is, as you might have guessed from the title, the coordinates that we labeled onto our unit circle. So in order to do this process, we need two things. First is the unit circle that we completed previously, and the second is actually what we just saw in the do now today. We need to know which coordinates are referred to by which trig ratios. So here is the unit circle, or as much of it as I can fit on one page that you did previously. So this unit circle now is complete. We have, over the course of the last several months, been adding one little bit at a time, and then we go off in this direction to that direction. We come back to the unit circle, we add one more piece. So we've got all the angles on the unit circle. They've all been labeled in degrees, they're labeled in radians, and now we have found, using special triangles, the coordinates for each of the 16 points around the unit circle. So we're going to need this in order to have access to the coordinates. The coordinates never change. Every unit circle is the same because it's a unit circle. It's got a radius of 1, so the coordinates don't change. These are the coordinates that we use every time. If we are evaluating trig ratios, use the unit circle. Okay, the second thing we need is we need to know which trig ratios refer to which coordinates on the unit circle, and how do we put the coordinates together to get an answer. So we saw already in the do now sine, cosine, and tangent. Sine is just going to refer to the y coordinate, since the hypotenuse of a unit circle will always be 1. That's the radius of 1 unit. So divide by 1, the hypotenuse we can ignore, basically. Right? And the opposite side is always going to be the y coordinate. So sine is the y coordinate, cosine the x coordinate, tangent is the y coordinate over the x coordinate as a fraction. And then the reciprocal ratios, cosecant is the reciprocal of sine. Okay, so there are two different ways we can describe the process of getting a reciprocal. The way our textbook describes it is what I have circled here. It's 1 divided by the y coordinate. Completely accurate from a mathematical perspective, it is true, you would get the same answer. It's a little bit harder to do, however. The other way we can understand what a reciprocal means is we remember that reciprocal means you could take a fraction and just flip it, or trade the numerator and the denominator. Since almost all of the coordinates on the unit circle are already written as a fraction, this is really, really easy to do. We just look for the appropriate coordinate. In this case, it would be the y coordinate, and then switch the numerator and denominator in that coordinate fraction. Okay, secant is the reciprocal of cosine, and so it is in the textbook written as 1 divided by the x coordinate, but we're just going to take that x coordinate and do the reciprocal of that fraction. And then cotangent is the reciprocal of tangent, which means we'll have the x coordinate on top of the y coordinate in our fraction. And just a word of warning ahead of time, tangent and cotangent are going to be the messier ones because we're going to get fractions. We're going to be able to clean them up some, but for both tangent and cotangent, you've got a y coordinate and an x coordinate put together, one on top or the other on top, into a fraction. The x and y coordinates usually are fractions themselves. So it's like taking one fraction and another fraction and putting those fractions into a third fraction. So you end up with a triple stack fraction action. It's going to take a little bit of work to get the mess cleaned up on those. So we'll look at those in a minute. Okay, so examples. First example, if we're asked to find something like sine of pi over 3, okay, here's what we need to do. We're going to say, all right, it's asking me to do sine. I just wrote into my notes, I memorized that sine refers to the y coordinate. So what I need to do is go to my unit circle and locate this angle. Pi over 3 is an angle given in radians. I've highlighted that on the unit circle already. So I'm going to find where pi over 3 is, and then I've got my coordinates listed there. Sine refers to the y coordinate. So I just pick the y coordinate as radical 3 over 2. Write it down, circle it, blam. Next example, how about cosine of 11 pi over 6? So again, inside the parentheses, that is the angle, so I need to find 11 pi over 6 radians on the unit circle. Cosine is telling me I need to report back as my answer the x coordinate. So I've highlighted that angle here in green, and when I look at my coordinates, I see that radical 3 over 2 is the x coordinate for this one, which, if you're paying attention, was the same answer we got last time, which maybe is not a surprise because on the unit circle, there's only 5 different numbers that show up over and over and over again. There's a 0, there's a 1, there's a 1/2, radical 3 over 2, radical 2 over 2. They show up in different combinations as the x coordinate or the y coordinate and positive and negative and all those different things, but there's only 5 numbers there. So we're going to see the same thing a lot. Okay, next example. How about sine of 7 pi over 6? All right, so I found the 7 pi over 6. That is the angle in radians on my unit circle. Any improper fraction I know is going to be in the bottom half of the unit circle. So if you're having trouble locating where angles are, um, anything that's an improper fraction is going to be the bottom half of the unit circle. So 7 pi over 6 is here. Sine refers to the y coordinate. I've highlighted that as negative a half. Write it down, circle your final answer, done. Okay, so how about tangent and cotangent? Both of those, we need to look at some examples for each of them. Those are going to be a little bit messier. We have some interesting things that show up. So for tangent of pi over 2, I got to find that angle. Pi over 2, I've highlighted that's straight up, like 90 degrees if we wanted degrees. And my two coordinates, the x is 0 and the y is 1. Tangent, of course, is the y coordinate on top, the x coordinate on the bottom. So when I set this up, 1 over 0, that gives me a division by 0, which is not possible. My final answer is undefined, or if I am doing a WAMAP problem, I'm going to write that as D, N, E for does not exist. All right, how about another tangent problem? So I got tangent of 3 pi over 4. So I found 3 pi over 4 on the unit circle. I've highlighted my x-coordinate and my y-coordinate. And in this case, they're almost identical. So I got radical 2 over 2 is my y-coordinate. That goes on top in blue. I got negative radical 2 over 2 is my x-coordinate. That goes on the bottom of my tangent fraction. And if we momentarily ignore this negative sign right here, we can ignore the mess and just say, you know what? That's a number divided by itself. So I know the answer has to be 1. And then we can't continue to ignore the negative sign. So technically, it's a number divided by negative itself. So my answer is negative 1. I don't actually have to worry about any of the radicals or the over 2s or anything. It's just, you know what? It's the same thing divided by itself. Throw the negative on your answer. The end. All right, well, how about a cotangent? Just for good measure, we'll throw one of these in here. And just by chance, this is actually the only one where we're going to end up with a triple stack fraction action that we're going to have to clean up. These happen with a tangent also, just not the examples that we looked at the last couple of minutes. So here we go. Cotangent of 2 pi over 3. So I found that angle, 2 pi over 3, on my unit circle is right here, highlighted in red. I got my x coordinate is green, negative 1/2. The y coordinate negative, radical 3 over 2. For cotangent, it's x on the top, y on the bottom. So I've got my negative a half on the top, my radical 3 over 2 on the bottom. So triple stack fraction action, here's the way I say we clean this up. We're just going to rewrite this division. So instead of a triple fraction action, let's make it division of fractions, which I know sounds worse, but it works a lot better. So I'm going to take the negative 1/2 divided by radical 3 over 2. So this is exactly the same meaning. It is the exact same mathematical operation. It's just division written one way or division written the other way. And then I can say, well, you know what, some dividing fractions here. I know that dividing fractions means I'm going to multiply by the reciprocal. So I'm going to rewrite the division problem. It was originally a fraction and then a division problem. And now I've changed it to a multiplication problem here at the end. So negative 1/2 in green times 2 over radical 3. So I have to do the reciprocal of that blue one, multiply straight across the numerators to get negative 2, and straight across the denominators to get 2 times radical 3. I can clean that fraction up. I simplify. I've got a 2 on the top and a 2 on the bottom. Those cancel. Maybe you noticed that earlier in the process and you just want to cross cancel before you even multiply the green and the blue together. That's fine. Depends on when you recognize you can simplify it. Um, but you do have to remember that when you cancel things, they don't just disappear. Because if you were to write negative radical 3, you'd be wrong. So 2 divided by 2 right here, 2 divided by 2 equals 1. And so you've got to have this 1 in the numerator. Because when you cancel things, they don't just cease to exist. All you've done is said, I've divided something by itself, and the answer is 1. Normally, that 1 doesn't affect anything. But in this case, since there's nothing else left on the numerator, we've got to have that 1 there. Otherwise, we're going to be totally off base with our answer. So negative 1 over radical 3, which, if you're astute, paying attention and remembering what I said yesterday, you can't leave that. That's not good grammar. We can't have a radical in the denominator. Now, I do want to point out, it's going to be a helpful thing to remember where that radical 3 ends up and where it came from, because it's going to help us in some future problems. So I was going to make a note of that in your mind right now. We'll come back to it later. Okay, so I need to rationalize this denominator. So if I take negative 1 over radical 3, and to rationalize it, I'm going to multiply by the square root of 3 over the square root of 3. And that is going to give me negative radical 3. And I'm going to do some mental work here. Radical 3 times radical 3 in my denominator is going to give me radical 9. And 9 is a perfect square. I can do the square root of 9. It is 3. Okay, creative pen. Second set of stars. So in the stars, those are equivalent answers. The first over here on the left side is bad grammar. We don't want to use that, although it doesn't mean the same thing, but it's not what we want. So negative radical 3 over 3. Final answer